come from a sincere and humble heart. I humbly request Ms. Yasmin Noor will have start to recite a verse from the Holy Quran.
Assalamu alaikum wa rahmatullahi wa barakatuhu. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغلوب عليهم ولا الضالين آمين. Surah Al-Fatiha, the opening. In the name of the Allah, the gracious, the merciful. Praise be to Allah, Lord of the worlds, the most gracious, the most merciful. Master of the day of judgment, it is you we worship and upon you we call for help. Guide us to the straight path, the path of those you have blessed, not of those against whom there is anger, nor of those who are misguided. Sadaqallahul Alim. Assalamu alaikum wa rahmatullahi wa barakatuhu.
Wa alaikum salam wa rahmatullahi wa barakatuh. You are enough. You have influence. You have a contribution to make. You have a gift that others need. You are the change. Your actions define your impact. Your words matter. I am profusely elated to call upon our righteous Vice Principal and the Head of the Department of Computer Applications, Dr. M. Nazreen Banu, to introduce the guest of today's session.
Good morning, everybody. The secret of success is the consistency of purpose. On this cheerful morning, it's my proud privilege to extend a warm and cordial welcome to all the dignitaries, guests, members of staff and students to the International Seminar on Robotics and Machine Learning. First of all, with great pleasure, I would like to welcome our resource persons of this morning session, Mrs. A. Nusrat Hamida, the research scholar, Department of Information Technology, Nagoya Institution of Technology, Japan, to spare her valuable time with us. I am really happy to welcome you to today's function, ma'am. Next, I extend my cordial welcome to our resource person of the afternoon session, Dr. Jabin Sultana, Assistant Professor, College of Computer and Information Sciences, Majma University, Saudi Arabia. I am grateful for you for readily accepting our invitation. I welcome you, ma'am. I feel honored to welcome the faculty members from other colleges, the participants from industries and student participants for this gracious occasion. I heartily welcome all of you. Wish you all the best. Thank you.
I am extremely delighted to invite our chief guest, Mrs. A. Nusrat Hamida, Department of Information Technology, Nagoya Institute of Technology, Japan, to take over the session.
Thank you. Thank you for the beautiful Kirat and
before
everyone.
Nusrat Hamida, our resource person, start the session, let me give a small introduction about the resource person, Mrs. Nusrat Hamida. It's my great privilege to introduce her in this wonderful session. She is currently pursuing PhD degree in Nagoya Institute of Technology, Japan. I'm proud to say that she is a great granddaughter of the famous Indian politician Qaide Millat Sahib, who is the freedom fighter, the great leader and the founder of Indian Union Muslim League. Mrs. Nusrat She has completed her BE Electronics and Communication degree at Tirunelveli, and then she joined Madras Institute of Technology for ME Avionics. Avionics means it's a study of electronic systems and equipment specifically designed for aircraft and then artificial satellites and then spacecraft. In that course, in ME, she got gold medal. Immediately, she got appointed in an aircraft designing manufacturing company in Hyderabad. She was working there for 3 years. Then she was selected for mixed scholarship, that is, which is a very prestigious scholarship given by Japan government. At present, she is pursuing doctoral degree at Nagoya Institute of Technology, Japan, in the field of robotics. Her interested fields are avionics, robotics, and haptics. It's our great honor to have such an eminent personality with us. Thank you, ma'am, for joining with us. Now, I hand over the session to you, ma'am. Please proceed.
Thank you so much, ma'am. Let me share my screen. Is it visible? Can you hear me?
Yes, ma'am. Visible, ma'am.
Is it visible?
Yes, ma'am. Yes, ma'am.
Okay, thank you. So thank you for the beautiful introduction, but I must correct, I'm not like the direct granddaughter, but yeah, we are very much related. And I'm Nusrat Hamida, and now we're going to have a presentation on emerging trends in robotics. You have already have a brief introduction about me, and I have a bachelor's degree in electronics and communication engineering from National Engineering College, Kabilpati, master's in avionics, Madras Institute of Technology, Crumpet, and I have a few years of work experience in Rockwell Collins India Design Center. I'm currently doing a PhD in Information Technology in Nagoya Institute of Technology. Especially, my research area is remote robot control with force feedback. So this presentation consists of like following things. The first one is the history of robot and robotics and the recent trends in different kinds of robots. So to start with the history of robotics, at around 270 BC, an ancient Greek engineer named Cetibus designed water cloths with movable figures. So this is a depiction of what he has made at that time by a 17th century French architect Claude Perrault. I mean, the Cetibus was said to be a barber, and his first invention was said to be an adjustable mirror for his barber shop. So just imagine how his inventions, we are talking about after these many years, he was a barber at first. And next thing was, there was a Muslim inventor called Al-Jazari during the Akhbar dynasty who designed and constructed a number of automatic machines, including kitchen appliances and musical automata powered by water. This was a picture that depicts the musical automata that was powered by water. It was used to entertain royal guests during parties, and it was designed in such a way that when the pegs of the drums hit the drum at different places, it produced different tones, and it was considered one of the best musical automata in the world. And when we are talking about engineering and automation, we can't defy the contributions of Leonardo da Vinci. And this is the model that has been developed from the notebook that was recovered around 1950s. It was said that Leonardo da Vinci has drawn the setup around 1490s period. And so here we are with Japan. So around some 17th to 19th century, mechanized puppets were very famous in Japan, and the main thing is karakuri ningyo. Ningyo is doll in Japanese, and the name karakuri is thought to come from the word karakuru, which means to pull, stretch, and move a thread. So it's like by pulling, stretching, and moving a thread, we are making the doll to act however we want. It was a mechanical puppet that was designed in 18th century Japan. And so we have had some history of robots. So where did the word robot comes from? The word robot was first coined by Czech writer Karel Čapek in 1921. In Slavic language, robot means forced labor. I mean, Čapek has written a play called as Rossum's Universal Robot. In that, he depicts humans as uh, robots which doesn't have any soul or brain and was given to the slavery. Just imagine it was 1921 and we are here is 2021. It's been 100 years. Someone's imagination was said to be a premonition for the recent developments. So, what is a robot? Robot is a man-made machine programmable by computers. It receives, processes, and acts on commands. In recent years, the robots are taught to think and act like humans thanks to artificial intelligence. So we have seen about robot. What about robotics? The word robotics was first coined by Isaac Asimov in 1942. He also formulated three laws of robotics or Asimov's laws. And Isaac Asimov is a science fiction writer. I mean, he was in academia for a few number of years, and then he turned into full-time science fiction writer. He has a PhD in chemistry. So he formulated these three laws of robotics in his science fiction. So the laws are: a robot may not injure a human being or through inaction, allow a human being to come to harm. A robot must obey the orders given by human beings, except where such orders would conflict the first law. A robot must protect its own existence as long as such protection does not conflict with the first or second laws. And later he added a zeroth law. This is like a main law. And a robot may not harm humanity or by inaction would allow humanity to come to harm. I mean, you must have heard about Isaac Asimov's science fiction called as I, Robot. If you have watched a movie called as I, Robot, that is loosely based on the science fiction by the author. So, what is robotics? Robotics is a branch of technology that deals with the design, construction, operation, and application of robots as per Oxford Dictionary. Really, robotics, I mean, if you consider me, I can say robotics is applied engineering that's like an amalgamation of different kinds of engineering. And it has mechanical parts, it has artificial intelligence, computer engineering, and there are so many things that's going into the robotics. So, what was the first patented robot? I mean, we are talking about different robots in different centuries. What was the first patented robot? The first patented robot is developed by George DeWall in 1954, and it is called as Unimate. This Unimate was adapted by General Motors, and they have used it in their manufacturing factories. So here is a small video, but there was some problem with the video and we couldn't hear the sound, but I think the video is self-explanatory. Here you can see the Unimate. It is an immobile robot. It's programmed to do a particular set of tasks. It has hands and it can hold object and move from one place to another, which was very surprisingly uh, odd at that time. I mean, it was a very high technological development at that time. It's like 1954, 70 years back, around 70 years back. Yeah, so that is the Unimate. That was the first patented robot system. It was developed by George DeWall. So, when you consider the modern robotics, what are the expectations we have from the robot? So, obviously, so we have a numerical control. We saw the example of numerical control in robotics as Unimate, and nowadays we are expecting it to be a self-programmed, autonomous, and it should be able to be controlled remotely. And the second one is it should be able to work on dynamic environments. So it should be designed and controlled to work in dynamic environments, and it should have high mobility and intelligence. What is a robot without a mobility nowadays? With artificial intelligence and so many algorithms for navigations, these are our expectations. So a robot should be flexible. So what do you mean by flexibility? So just if we want to create a robot that depicts the human arm movement, obviously it should be able to move its hand as flexible as a human. So there are so many processes of again algorithms, actuators. It's like a combination, as I have already said, it's a combination of mechanical and computer engineering and so many other things, sensors, images, and electronics. And second one, so when we want the robot to work in a dynamic environment, we should have like human-like action in a dynamic environment. Dynamic environment in this case means like a plain surface or the one with the stones and everything. So we human have eyes. With the eyes we see and we just move away from the obstacle and follow a path. So what about robots? The robot needs different kind of sensors. Image sensor, motion sensor, and proximity sensor. And obviously, the next one is the navigation. It should avoid the obstacle and follow a particular path. So, for the navigation, proximity sensor and image sensors are very useful. And the recent kind of development in robots is for the rehabilitation use. For the rehabilitation, robots should be able to interact with the humans considering the different external and internal factors. So if consider if a human is crying, it should be able to sense the emotion and say something so that it can console him or her. And the next one is programming and command generation. To achieve all these things, the basic is like algorithms, which needs a robust programming to materialize what we are expecting. And the next one is artificial intelligence. As we all know, artificial intelligence is like most progressing technology which has a promising effects on robotics. So how does the robot work? Simple three-step process. The first one is sensing, the second one is planning, third one is acting. Just I have told you the examples like human interaction. So if there is a stone in a path, it should sense that there is a stone. It should plan to avoid the stone and move away from the stone and go to the particular destination and act on the plan. This is like a simple explanation of how does a robot work. So I have a small video of like Mars rover's high view, and it doesn't have audio. But here you can see a mobile robot. It has mobility. It has sensors, especially image sensor. Here you can see that. And it has a hand that collects the specimen that is needed from Mars, and you can clearly see it avoids the obstacles and navigate perfectly. Here you can see some stones, and the terrain was completely different. It was a dynamic environment. We don't know how the environment will be in Mars. And this is the path that is taken by the robot. It's collecting specimens and it's avoiding the rocks. It's checking. So this is how the robot normally works. This is a video from Jet Propulsion Laboratory, NASA. So now we are going for the recent trends. So I have picked a few in each category of robots because there are so many new developments, I mean, coming every single day. So I have selected industrial robots, humanoid robots, agriculture robots, domestic robots, and remotely controlled robots. Industrial robots. As the name specifies, industrial robots are mainly used in industries. And this is a picture of the Unimate that we have just seen. So this was the first one. I mean, at that time, Unimate was considered so powerful. It was very much a new, powerful technology. And let's see how things have progressed. Spot. First one is Spot. Spot is a robot dog that is designed by Boston Dynamics, and it is designed for goods, carrying goods through a warehouse, sensing and inspecting a remote site with an unfavorable environment for human operators. So if you say, I mean, unfavorable environment for human operators, consider some nuclear reactor accident. I mean, human cannot enter. I'm talking about in Japan. It was in 2011. There was a Fukushima incident, and human cannot enter the place where the accident took place. So just to see what is happening there, we need some kind of human-like or intelligent things to assess the area. So for that kind of area, Spot is a better robot to be deployed. It has 360-degree perception, it has a high temperature tolerance, and it has an API and flexible payload interface. So just to give some more explanation, it has stereo cameras enable remote control. I mean, Spot can be programmed, I mean pre-programmed, or it can be controlled remotely. And see the legs. The legs are very flexible, as much as similar to a dog, and it can move in different kind of dynamic environments with the legs like this. And it has customizable software control, and it can carry up to 14 kilograms in very dynamic environment. Next one I would like to introduce is Aquanaut. Aquanaut is developed by Houston Mechatronics, and it is an advanced unmanned underwater transformer. So we have seen Spot, which can be worked in land, and this is in water. So it can transform itself from a long distance submarine into a half humanoid robot. It can do complex underwater manipulation tasks, and it is used to inspect subsea oil, gas infrastructure, operate valves, and use subsea tools with just a few mouse clicks. It has a maximum operational depth of 984 feet. So just imagine there was some oil leak, and it's so it was in a very into the depths of the ocean. I mean, we can deploy Aquanaut to go and repair that. Just to say how it is called as why it is called as a transformer. If you know, if you see, if you have seen the film Transformer, you know it is an Aquarius Prime or something like that. The car can be transformed into a robot. It's somewhat similar, and let's see how it transforms itself into. So it was a submarine. It's just transforming into a fully fledged half humanoid. It's not a full humanoid, the half humanoid. It has hands, it has, I mean, image sensors, cameras, light, and this can also be programmed to remote control, to be controlled remotely. So these two are the main industrial robots. The next one is the exoskeleton robots. Exoskeleton robots are robots, or usually called as a legs and arm support system. These are used. These are. I mean, you have to wear it like a backpack. So can lift around 200 operators, can lift around 200 kgs, and operators will just feel like they are carrying a 5 kilogram load. So we can say that this will make you feel like an Iron Man. To reduce workplace, this is used to reduce the workplace injuries and to help older people to work longer. Especially, I mean, in rapidly aging population like Japan, these kind of exoskeletons are very useful. These exoskeletons can also be used for rehabilitation purposes. I mean, like if you are going through a physiotherapy, you always need somebody else to help you when you first starts walking. So at that time, these kind of exoskeletons can also be used. So if we consider a robot, usually we name them as like categorize them as industrial or domestic, but every robot can have multiple uses. The next one is our everyone's favorites, humanoid robots. Looks like human, acts like human, sometimes things like human. So this is Pepper. The robot's name is called as Pepper, and this is from SoftBank Robotics, Japan. Pepper is world's first social humanoid robot. It recognizes the faces and basic human emotions. It interacts with humans very well, and it can hold a conversation, and it has its application on domestic and industrial arena. So this is a picture of Pepper that has been deployed, I think, in Saudi airport to help the passengers to uh, with any questions or queries. And you can see a small boy is interacting with the Pepper, and Pepper has the tablet attached to its chest, so you can input like you can press the buttons to have a conversation with Pepper. And Pepper, obviously, as I have already told, it recognizes basic human emotions. So if you're crying, maybe it will console you. And it can also be used in industries, especially in human resources department, because it can hold a conversation, it can collect the data, which are like very, it can sometimes analyze the data. So it is very useful, and currently in their website it was told that it is used in 2000 different locations around the world. Next one is Digit, and it is developed by Agility Robotics. So this is a bipedal uh, humanoid robot. If you see Pepper has only one. It, it doesn't have legs. Pepper doesn't have legs, but here you can see it is a bipedal humanoid robot that can carry stacks of boxes up to 18 kilograms. It can navigate through a complex human environment, like if somebody is coming to deliver you some packages, obviously they have to climb up the steps, and if there is something in the middle, they have to navigate through that. Agility, Agility's Digit can do that very well. So, and it can also be used for taking care of people at home. And currently, Agility has a collaboration with Ford. In the case that the just imagine we are there is some delivery coming for you from Amazon warehouse. So from the warehouse to the home, the Ford's autonomous vehicle will carry the parcel, and once it's at home, Agility Robotics Digit can carry the parcel to your doorstep. Such kind of collaboration or progress. Atlas. So Atlas is one of the best dynamic humanoid in the world. It has very high power, advanced control systems. It has algorithms that facilitate complex locomotion, and it has predictive and real-time perception models. I mean, this is one of the best um, humanoid, dynamic humanoid robot. I mean, I have a video for you. I mean, I can say so many things and explain things, but if you see the video, you will understand how dynamic this robot is. Again, it doesn't have the audio, but just see how, I mean, even I don't think I can do these things. Just imagine we have come from Unimate to this one. 70 years of technology and continuously progressing. So it can just take the steps. It can zoom us out. Yeah. That is Atlas by Boston Dynamics. And the next one is agricultural robots. So agriculture is like what gives us everything, food, clothes, and everything. So incorporating robots in agriculture to reduce the manual labor is uh, very useful nowadays. And I have a few selection of the agriculture robots. This is called as autonomous breeder that is developed by Carbon Robotics. Mm, this autonomous breeder is very much helpful to weed. Just imagine you have a garden and you have just planted some seeds and there comes unnecessary plants that are called as weeds. And so our garden is somewhat smaller and we can do the manual work. What about if we have some acres and acres of land and we need to weed? We can use autonomous weeder. So autonomous weeder uses machine learning to identify the weeds and uses laser technology to kill them. It patrols every night, identify the weeds and destroy them. It is said to have the capability to read around 100,000 beats per hour with 8 laser modules. And the next one is apple picking robot. This apple picking robot is developed by Australia's Monash University Department of Mechanical and Aerospace Engineering. It has a hand that picks the ripe apples. It has sensors and image processing algorithms to do that. And we know like the robot's hands may harm the apple, but these have sponge-like structure so that it carefully picks the apple and gathers it. This is very helpful likewise when you have acres and acres of land and reducing the manual labor. The next one is domestic robots. So domestic robots are, I mean, we can say they are used for day-to-day, helping with the day-to-day activities or rehabilitation or like cleaning, cooking. There is a cooking robot. And let's see what we have in the domestic robots. So first one is Bot Handy. Bot Handy is designed by Samsung Robotics. It is a home care robot with AI. It recognizes and interacts with you. I mean, if you're looking at your phone and scrolling through social media for 2 or 3 hours, it will ask you to stop. So it has that kind of artificial intelligence. It just sees you and watches you, and it will wake you up. And it has alarm, alarm section, and it interacts with you, and mainly it helps with washing dishes, laundry, and other homes. Just imagine I mean, everyone has a Samsung bought handy at home for washing dishes. It just take the dirty dishes and put it in the dishwasher and set the timings. And the same for the laundry and other home needs. And it is said to be still in the development process. And the one that we are waiting for is a robotic agent. This is developed by Muli Robotics. So this is the first. This is like a complete setup. It has hands. It has like a particular area for the ladles and all the other things. We just need to cut and put it in the particular place. So it will cook. It will cook clean. It has sensor. I mean, here you are like entering what should be done at what time for breakfast, this, for dinner, this. It was said to be able to use blender too. So here it's making rice, pasta, and Alfredo. But it was said to be cost around $700,000. But we can hope, like, I mean, when the cell phone was first invented, it cost more dollars, right? But now everyone has cell phones, so someday it may become a norm in every other household. So the final one is remotely controlled robots. Remotely controlled robots are the robots which you can control from a faraway place. Just imagine there is a robot. Just imagine this robot is in India and just me, I'm in Japan. So with here they have used virtual reality. Virtual reality, you can make the robots move and do whatever you want to do, you want them to do. So this is a robot that is developed by Massachusetts Institute of Technology, Boston, and they have used a virtual headset and virtual reality for remotely control the robot. The first one is the Ricci. Ricci is developed by a French robotic company called as Poland Robotics. So it's like a similar to what we have seen in the previous slide, but Ricci just have a torso. It doesn't have legs. It just move with the wheels. And again, we have used the virtual reality technology. And this robot, I mean, you can have this at home, and you can just, I mean, if you forget, just imagine you have forgot to switch off the stove. I mean, I do that so many times. So if there is a Ricci at your home, and you have the virtual reality headset and hand things, you can make Ricci to reach the stove and stop it. Just imagine how beneficial it can be. It can helpful with just like domestic, and it has domestic and industrial applications. Next one is tele-existence robots. So this is similar to the Ricci, but the main thing is this is recently they have a trial run for tele-existence robot in a convenience store in Japan that is called as Family Mart. And without the explanation, let me show the video how it's done. Obviously, there is so many algorithms programming and so many testing and trials and error to get to this level. So this is the convenience store. So this guy is at his lab. And he's doing his work with a global pandemic we are having now. I mean, nobody wants others to touch their food, especially. So this is like one of the best technological innovations. Well, with that, especially the remote control robot and remote learning come into prominence after. I mean, everybody knows that now, like Zoom and everything. I mean, we are having a seminar remotely. So just see how carefully it takes a bottle and puts it in the rack. And the final one, and which is like very much needed and but it's very crucial to consider as a telesurgery. So we have just seen robots in domestic and industrial settings so far, but what about in medical setting? So this is a picture that was depicted in my Shinshinkun, here a newspaper in Japan, and this doctor is doing the surgery on a patient remotely. I mean, here they are very near, but this is like a first step to something like some doctor from US doing a surgery in a patient in Japan, and just consider it's like a very emergency situation and we need to operate in an hour and the surgeon is in US. We can use telesurgery for that. I mean, this is like still in like development progress. This is what we're talking about is life. So it's still in progress. And the main thing to consider this is the sense of touch. Usually, before making an incision, a surgeon will touch and feel and then make an incision. So the technology called as haptic technology comes into play at this point. So haptic technology is nothing but the sense of touch. You can perceive the sense of touching a different texture by using the haptic technology. Uh, that is facilitated by perceiving the force that is experienced. Just to explain the force that is being perceived, just consider two balls. One is made of sponge, the another one is a basketball. Sorry, baseball, basketball. And if you just press a sponge ball, the feeling and the force, in technical terms, the force you perceive from a sponge ball is completely different from the force that you will be perceiving uh, or you will be feeling from a baseball. Or just imagine, to be in simpler terms, just imagine cake and wood. Cake will be very spongy, but if you touch wood, you can feel the difference, right? That can be uh, modeled into a machine, and that sense is called as the sense of touch haptic technology. So haptic technology plays a major role in telesurgery, and even in India, at IIT Madras, we have touch lab that is have a collaboration with Massachusetts Institute of Technology, and the professor there is from he did postdoc from MIT, Boston. I mean, they are trying to like replicate Varma Kalai. I mean, it's like sense of touch, right? You have to touch and take out the knots. That is the Varma Kalai. So they are also doing a research instead of like Western medicine. It's like our own Indian medicine kind. So this is about the telesurgery. And the final one I want to, this is like more like a drone and a robot and so many things combined. This is the insect-like robots. I mean, you can see there are four insect-like things with wings. Each one is around some 5 centimeters. It's less than 5 centimeters, and it has wings. It can navigate itself, and if it collides with something, it can get up easily. Uh, and this is developed by MIT Boston, and this is how this works. And this has the subtitle, so I think it's self-explanatory. So this is how small it is. It's very small, around some 5 centimeters. So when pushed down, just gets up. it also do somersault. So as I said, it's very small. It's like a bumblebee. So that's it. That's about insect like robots. So I have like a few points about my research, what I do in my PhD. My research mainly focuses on remote robot control with force feedback. We use haptic technology. And just like remote robot control means controlling a remotely located robot. And haptic sense is used to perceive the force from the robot. And my research mainly focuses on communication and networks problem. And we have seen like uh, in here, if you see, uh, we have seen that the person is in another place. The robot is in some remote location. So at that time, we have to send information, the information that he is moving his hands to take the bottle. So we have like information channels for that. What if there is some delays with that? So see, if you see here, he moves that, and the information is sent to the robot, and it moves its hands. That is called as a remote control. So mine is that what if there is a delay? Just imagine you are streaming a video in YouTube, and there was some delay, and the video was stuck. It's just a video, and you are at your home. Just imagine that is like very critical real time environment. At that time, we can't uh, like allow delays. So my work is to literally reduce the influence of the network delay between the two locations. Yeah, that's what I do in my research. And I have a small video. I think we have time since it's like a 40 minutes presentation. This is like how agile the robots are. I mean, it's a very good video to watch, just for even for the entertainment. And the main thing is that the main problem is here is that it doesn't have sound. I mean, they are dancing for a song. These robots are dancing for a song, and this is the one we saw, Atlas. And Atlas will be joined by Spot. You can see how we have developed from, as I have said so many times, how we have developed from an Unimate to Atlas and Spot in 70 years. This is like a work of different engineers and programmers and data analysts. That's why it is called as the most agile robot. It's like most probably replicating a human. It was programmed to do so. So we study C, C++, and every other programming language to say hello world, but we can also do these things. Just see how dynamic the movements of the spot is. It's like seeing an animation picture, the dog dancing. It also, the spot also has like external payload, the hand here. I mean, I can't do that. Most of us can't, right? The stability it requires in the algorithms and the different kinds of data and the different kinds of trial, the number of trials they must have done to accomplish this kind of technology is astonishing. Yeah. So this is how the robotics have emerged in these recent years. Thank you. Thank you so much.
I kindly request the participants to post the ask your queries or doubts in the chat section.
Yeah. Good morning, ma'am. Yeah. Yeah.
Yes.
Yeah, good morning, ma'am. So, ma'am, which tool we can use to develop develop the robotics programming, especially?
So
How?
see, that's what I have told. I mean, even for the Mars rovers, the first video I have shown, they have used C. Even in our lab, we use C for developing the algorithms.
Yeah. In
And
the master.
we have also considering using Python when we talk about artificial intelligence.
Yeah. In my master degree, ma'am, I use C programming for designing a PID line follower robot. In my master degree, the final project. And I use the Arduino. Arduino Uno. That's
Yeah,
the
but I mean, we don't use Arduino. We have used Arduino in my masters like 10 years back. My friend has a project for a robot. I think it's similar to yours. It's like a combination of land and drone exchanging information. She has used Arduino. I know Arduino. Yeah.
yeah. Okay, if I want to develop some telesurgery robot, so what are the advantages or which are the leading fields in the telesurgery robot?
I mean, if you consider telesurgery, it can be only used in medical field, right? So, for the remote uh, control robot, that is like a broader perspective. With that, you can use it everywhere. Even now, you can use it for like there was a recent development in which the persons with different disabilities like paraplegic and uh, different disabilities are using their eyes, just their eyes, with their eye movements. They are controlling robots in restaurants. So it's like giving the jobs to people who cannot even move. If you consider teleoperation, that is like a bigger perspective. Telesurgery, we can use it in medical field. Teleoperation is a bigger perspective. So there are so many things, and also you can, I mean, how we have learned to write things, right? Our our parents used to teach us how to write by taking our hands. We can do the same kind of things with haptics and teleoperation. So there are so many possibilities. Whatever we human are doing every single day, we can design them with robots. But it's going to take some time. But yeah.
Yeah, ma'am, actually I'm from the electronics and communication background, so I think robotics is maybe helpful or maybe the leading field to give me a proper field, a proper job uh, in nowadays. I think.
Yes, I mean, especially with this pandemic and everything, we need someone or something else to do work for us. Obviously, it's like a leading field.
I want to also join PhD degree after some days. So I think robotics. I was also doing some works in the field of robotics. So this may help. This may helpful in my future, and I can do uh, mm, the master degree. Sorry, my PhD degree in robotics. It may be helpful. Yeah,
Yes.
choosing the field.
Yeah, I mean, you have to choose a field and a college and a professor uh, that works well with what you have done already. So in that case, obviously, it will help you a lot.
Ma'am, can you consider some universities which can help me in India, especially for the PhD degree in this field? Yeah, have some knowledge.
I would obviously say IITs, But I mean, I completed my masters around 7 years. I'm not sure about things in India, India much, but I would
Actually,
say just choose the colleges that have opportunities or like some collaboration with other countries so that you can learn so much here and you can go somewhere like US, Europe, Germany, France, somewhere else and learn that too. Just maybe
ma'am, yeah,
just go through different kinds of what are the publications they have done. It's like a lot of reading before deciding a PhD. It's like a lot of reading, lot of research, and then decide that. I think that would be better.
Actually, the problem is about I've done my degree in Master of Science in Electronic Science and Technology, and from IITs and all the technical universities are not considering us for the PhD degree. They are also looking for the MTech scholars. So that's a very big problem. I've since here from 2019. So I really planned something, but it's not working properly. So
If
it's not
that is the
IIT.
case, maybe you can try like fully paid scholarship at some other countries because I think in India we have so many hurdles for like people can only do PhD in this field if you have like some engineering degree. You can try for other countries. I mean, they will pay they will waive this tuition fee, and you don't have to. They will also provide you with scholarship for living. But with
Yeah.
pandemic, it's a bit difficult, I think. But you can try.
Ma'am, which country can I try for? Which country? So this can be helpful
It
in the
it really depends upon which robotics you want to. I mean, concentrate on. I mean, I have shown so many things. We have USA, France, even Germany, and Dutch, Denmark, and Japan. Obviously, Japan. But it depends upon your interest and the research you do.
yeah. Thank you so much, ma'am. Very informative session and
Thank you so
nice
much.
perspective. And I'll got my all answers. Thank you so much, ma'am.
Thank you.
Ma'am, I have a question.
Yes.
Ma'am, I just found out online that Oculus has discovered mind control. Do you know anything about that?
Oculus?
The company Oculus has made a VR headset that can function just by your thoughts, can read your mind and do stuff.
Uh, I mean, to be frank, I mean, I'm not sure much about VR, but I have seen some like when I was doing some other research looking for like technological update. I have seen some. I have read some papers on controlling with eye movements. I'm not sure about thoughts. That seems that may be possible. Obviously, we have technologically progressed so much that may be possible, but I haven't heard of that. But I have seen people trying to control, like switching on the fan with eye movement. I
Ma'am,
literally saw it happening in front of me. So I mean, if somebody is not able to move uh, like below their throat, like in that case, how will they operate like fans and lights at home? They need to call. They need somebody else's help, right? In that point. So I have seen them. They using their eyes to operate the fans, and this may seem simple, but it's like a very helpful for rehabilitation. I think if that is possible, obviously, the thing you are saying. Mm,
because there's a YouTube, they have like a bunch of videos that say VR mind control is here and it actually works. There's a video here about it, the entire thing, and it's also on
uh,
bunch of it's
if you
also on
ask
bunch of
me, even if the YouTube video, if there is a link for some research paper or if they have some data,
no,
I mean, I
not
believe data. I believe data. So I
not
mean,
data, actually live testing. We tested it in a video and they showed that it works.
mm, I mean, I haven't seen the video. Maybe I will check, and maybe I will get back some way. I'm not sure,
Okay.
but I mean, since that is not my proper research field, I'm not sure. I mean, I have seen some, but it's about you need data and you have to see the results by yourself. If it is from reputed organization, and then maybe it's possible. I'm sorry, I
Okay.
couldn't give you a proper answer because I'm not very well known in that sector.
Yes, ma'am. Thank you, ma'am.
No, it's okay, thank you.
Ma'am, can you share your PPT with us? Please?
Maybe I can send it to the organizers.
Okay.
I don't. If you can contact
Okay.
them, I think they have their email ID in the pamphlet notice. So maybe if you contact them,
Yeah.
maybe they can. I will share that with them. Sure.
If I want to contact with you, ma'am, then I can through the email ID also. Can you?
Okay, maybe I will include my email ID in the PPT, so you may be able to contact.
Okay. Thank you so much.
Yeah, it's okay.
Audience, do you have any other question?
Excuse me, ma'am. Excuse me, ma'am.
Yes.
Ma'am, have you ever, this is Mohammed Zahid from Abu Dhabi. Have you ever incorporated biology in any of your projects?
Uh, so the most biologic thing that we have used is the perception of the sense of touch. Other than that, we didn't use much. But I have seen. That's what I mean. I have attended so many conferences. I have seen some bionic humanoid that is developed by Nagoya University. If you want to check something related to biology, right? You're asking about bionic things, right? Am I correct?
Yes, ma'am.
Uh, so you can search for Nagoya University, and they have developed bionic robots. And what my research perspective is, we have only done haptics, but the bionic arm and bionic things, I have seen some presentations by very well educated professors from Nagoya University, which is one of the best universities in Japan. You can check for Nagoya University, some bionics lab. But the problem is it may be in Japanese, but they also have English version, but Japanese version will be about a bit informative, I think.
Ma'am, you said that you were working with haptics, right?
Yes. Haptic,
So,
my main thing is remote robot control with haptics. So main uh, like keen interest is on remote robot control, and we are using haptic to for an added advantage in a communication perspective. Yeah.
okay, so what is your most significant advancement in haptics?
If you ask me about haptics, so far, even in the virtual uh, like robots we have seen, it is taking the bottle and putting it in the uh, like the rack, and even for the spot, it just sees the object obstacle and move away because of the image sensor. Okay. What happens if there is some miscalculation and it just collide with the particular rock? If you don't have any sense of the force that is experienced by the robot, you don't know, right? I mean, if there is some problem with some image sensor and it will collide again and again and again. So with the haptic sense, you can feel the force as if you are like colliding with the rock. And if one sense is not operating, we can use another, like sense in the meaning the seeing. If seeing is not working through the cameras, we can use this haptic sense to perceive the force and use that for navigation.
Thank you, ma'am.
Hello, ma'am. Someone raised a question. How big data is helpful with robotics, ma'am?
I'm sorry, can you repeat the question?
How big data is related helpful with robotics, ma'am?
Uh, so that's, I mean, even I have limited knowledge. Let me answer the question. So it's about, if you consider, uh, with my limited knowledge, let me say that again. I think we have another chief guest who is very well versed in machine learning. I'm not that much well versed, but artificial intelligence is that you are giving a number of data uh, sets to train a particular robot. That's what we do in artificial intelligence, right? So we are having all these different kinds of scenarios and we are inputting. So, and if you consider big data, we are gathering the data that is useful for us, necessary for us, from a large amount of data. That is big data to my understanding. So there is a possibility, because every single technology that is available in the world, I mean, what we have gone through years is like we can use everything and everything to make it to the next level. That's how modern robotics is what it is now. So it was just a stagnant, like a monster thing, machine thing. Now it can move, it can dance. So obviously that may be prospects, but that's what I said. I have very limited knowledge on big data. I'm sorry.
Hello, ma'am. One more raised a question. What technology is used in robotics?
Technology, I'm not sure by technology what do you mean, but as I've already said, it's like a different kinds of engineering technologies. Like, just imagine there is a robot, and for the image sensor to see, for the robot to see, you need image sensor. That is like electronics and communication. And to, so it's seeing and it's gathering the data. To collect the data, you need the proper computer, and for analyzing the data, you need proper algorithms. So computer engineering, and the structure of the robot is from mechanical, and for it to move like a human, it needs actuators, pneumatics, hydraulics, so many things. So that's about the, sorry, mechanical engineering. And also different kinds of engineering fields is involved. We think that it's a mechanical thing. No, it has so many things. So if we introduce that, the artificial intelligence into that, so we have like neurotransmitters and so many things, neural networks to be present inside the small computer we have. So it's like a combination of different technology. That's what I would say. Crediting a single technology or single field of engineering will not do like good for the other fields of engineering.
Ma'am, this is Mohammed Zahid from Abu Dhabi again. You have mentioned algorithms a lot.
Yeah.
So, can you give an example of like how it was used, like how it works and stuff?
Algorithm. Okay. Let me think. So, uh, the basic algorithm is about the predictive control. Okay. So you must have studied. Uh, if you're in, I think if you're in engineering field, you must have studied interpolation and extrapolation. So, so you're sending a data for the robot to move from position A to B. This is like very basic algorithm. A to B, and it will be done in an increment of steps. So you're sending the data, and consider it takes like 10 seconds, and it has moved for 2 seconds, and the data for the third second is missing. What will you do? So the algorithms, like a simple prediction algorithm, is that it will calculate the velocity, it will calculate the time and the distance, and with that, it will predict the position to move from like time is equal to 2 seconds to time is equal to 3 seconds. And then it will wait for the data to arrive for it to go to the fourth second. If it is not there, then again it will use the predictive algorithm to move to the next step. And if the data is available for the next time instant, it will get the data and it will move for the next step. So this is like a very basic linear predictive algorithm. And likewise, if you consider complex algorithms for collisions, it will collide. So it will have some force sensors within them, and it will calculate how much force is there. And uh, if the algorithm is like having a property such as like how much force will be exerted into the particular robot uh, when the distance is around some 6 centimeters, 7 centimeters, and then it will calculate, okay, the particular obstacle is at this distance. So we have to move, or we have to plan to move away from this path. These are like very basic algorithms.
Thanks, ma'am.
One more question, ma'am. Can you tell few points about telesurgery?
I think I have already answered the question in the first. The first question was about telesurgery, and it's like that. I mean, telesurgery is like doing the surgery. The surgeon, if the surgeon is remotely located, or the patient is remotely located, operating on a patient from a distance location is called as telesurgery. And to do that, obviously we should have like proper haptic sense and the proper knowledge of for the medicine doctor about all the different kinds of technology that he is using, and like it's like practice makes things perfect. So yeah, that's what telesurgery is. It's still in developmental stage, I'll say, because what we are talking about is lives. So
Okay, ma'am, it's Mohammed Zahid from Abu Dhabi again. Ma'am, you said that this telesurgery technology is useful if the doctor is far away from the actual operation site, right?
Yes.
So you do, but in since this machine is very advanced, you would, how strong of an internet connection do you need in order to do this perfectly?
That's what I mean. When you consider internet is not at all a reliable source of communication. Like, just imagine seeing a YouTube video, the same uh, example. It will stuck. What something stuck in the middle when you're doing a telesurgery. That's what we are doing. We are doing some. We are like researching about algorithms to use. These are like real time critical. What is it? Critical uh, operations, right? It's human life. It's like a real time critical thing. So it's that's what I told you. It's still in experimental stage. Maybe it's my assumption. Maybe there will be a secondary doctor who will be there. Obviously, there will be a secondary doctor when we talk about the human lives. We are like what we can do is make some controls to mitigate or reduce the influence of the network delays. Like predictive control, the same thing what I told was for linear prediction control. We can do that, but for that to apply it in a telesurgery, it's going to take a lot of experimentation and research to do so.
So they don't use internet.
That's what I mean. Any communication, what is it? Communication control is we can't rely. We can't rely on anything. That's what we have network delays. We maybe we can use internet in the future, or maybe they use the internet, but they have a secondary doctor. There are like so many risk assessment and risk aversion mechanisms that needs to be considered, especially when you are thinking about telesurgery.
Thank you.
அட்மிட் கொடுக்கறதுக்கு இங்கே நான் டெலீட் பண்ணுவேன். சரி மேம், நான் பார்க்குறேன். இது வேணாம். மேம் ஃப்ரீயாக இருக்குது அட்மிட் பண்ண சொல்லுங்கள் மேம் வரமாட்டேங்கிறாங்க அட்மிட் கேட்கல
I'm sorry, I have a network problem. I mean, that's what happens when you're using the internet. So I have a 4-minute video for how haptics work with virtual reality. People are interested, I can show that.
Yes, ma'am, that would be very useful.
It's like how visually challenged people uses haptic and virtual reality to see what they can't see in real life. Sorry, let me share it. 1 minute. It doesn't have audio. I mean, with audio, it just touches your heart. I mean, he's saying that he didn't expect it to feel like that. Usually challenged people touch the faces of other people to feel how they look like. So he's saying that he didn't expect it to be that much real. And this is about touching masterpieces. They are talking about the pieces in the museum because I mean we can see and appreciate art, but what about visually challenged people? I mean, you can see I think you can see their reactions, but I'm sorry, it doesn't have that audio. It's like he's telling that he always had this experience of by words they will explain the statues like that and this. Touch and feel is like a different experience. Just see him, he's so happy to touch that and feel it. Like you can feel the sense of touch. So he's saying that he requires somebody to help him every single time, but this time he can do it by himself. She's talking about the dress the statue is wearing. So he's saying that it adds to him something that is missing from him. So so he's saying that he can see it by touching. Yeah. Thank you. Most of the videos and most of the things, if you search with the company name, you can obviously see there are so many more videos for Spot and the remote control robot Trichy and teleexistence. You can also know about in depth about different technologies used. I think that will be helpful. Maybe I can add some the resources I have used
ఏంటి నేను
in the
ఇలా
PPT
నుంచి
while sharing with the organizing team.
అని ఇలా సరే సరే
Hello, ma'am. Someone raised a question. How MATLAB is supportive with robotics?
Uh, Currently, I'm not using MATLAB, but I have I have known people from industries who are using MATLAB in industrial mechatronics and robotics development. Yes, and when I studied my master's, and I mean, some of my friends has used MATLAB for simulation, and like simulation is always a very important part, right? Before going for the uh, particular hardware, and also they have used that for drones. So yeah, I think MATLAB can be used. They are using it that in industries. I can't spare more details, but they are using it in industries for mechatronics, especially autonomous vehicle development. It's like a robot, right? Autonomous vehicle is a robot.
Hello, ma'am. This is the final question. What is locomotion device in robotics, ma'am?
It I think it depends upon the robot. Locomotion is a process of moving from one location to the other location. So for athletes, you can see it has legs for locomotion for moving, right? Different robots have different kinds of technology they use for locomotion. So locomotion in robotics is that, I mean, technically speaking, it's a combination of again different sorts of computers uh, and mechanical engineering, actuators and pneumatics. How does it break what? Pneumatics, right? So it's a combination of different kinds of actuators and levers for the locomotion.
Thank you so much, ma'am. That was really a fruitful session. Gratitude is not only the greatest of virtues, but the parent of all others. I call upon our respectable Vice Principal, Mrs. B. Hamida Tamsim, Department of Computer Applications, to deliver a vote of thanks.
A very good afternoon to all. On behalf of our college and the entire fraternity of the institute, first of all, my sincere thanks to Almighty God for making this session a grand success. By His blessings and immense grace, we are able to make this session what it is. A good start always has a great end. This session has come to an end by enriching us with the emerging trends in robotics. My hearty thanks to our Session 1 resource person, Mrs. A. Nusrat Hamida, who spared time even in her busiest schedule to grace this session. Today we had an opportunity to hear your thoughts and this will be an encouraging us in the upcoming sessions. Your thoughts have enlightened our minds and it was indeed a great time having you here. I would like to thank all the participants for their kind cooperation and patient listening. Hope this session was informative. We will meet you in the next session with the same link at 2 o'clock. Until then, stay tuned. Have a good time. Thank you all.
Thank you so much for the opportunity. Thank you. Hope you all have a good day.